Okay, so the next topic is called z-scores. So let's suppose that we have a population, and let's suppose this is university students, and let's suppose we have n equals 5,000 of them. And suppose the variable that we're interested in is their heights. So we have student 1, student 2, all the way down to student 5,000. And let's suppose that the mean height for this population, mu, is equal to 160. And let's suppose we also know the standard deviation for this population. And let's suppose that it's 5 centimeters. So these are centimeters, centimeters. So that means that, let's say this is 160. And let's say this is 165. And this is 170. And this is 155, 150, and so on. Okay, so we said that the mean of the population is 160, so it's centered around here. Now, let's suppose that we have one of the students, say S150, or let's say FS2020 or something, their height is here. They are 165 centimeters tall. So let's call that student A. And let's say we have a student B, and their height is 170, and a student C, and their height is 155, and so on. So, of course, if we say, how much taller is A than the mean? Of course, they are 5 centimeters taller. And if we say, how much taller is B than the mean? Of course, they are 10 centimeters taller. And if we say, how much shorter is C? Of course, they are 5 centimeters shorter. So that's obvious. But what we can do is we can also, the standard deviation we said was 5. So we can use the standard deviation as like a ruler. So we can take this ruler and we can count how many standard deviations is student B above the mean. Let's write the mean. So how many standard deviations is B above the mean? So we want to take this ruler and figure out how many standard deviations do we have to go up from 160 to get to 170? And obviously the answer is 2. And what about A? How many standard deviations above the mean is A? And obviously the answer is 1. And then we can say C is 1 standard deviation below the mean. So if we want to, we could kind of make another scale underneath here. And instead of saying A is 165, we can say A is plus 1 standard deviation. Instead of saying B is 170, we can say B is plus 2 standard deviations. In other words, 2 standard deviations above mu. We can call this 0. We can call this plus 1. We can call this plus 2. We can say, well, okay, what is plus 3 then? Obviously, plus 3 up here would be 175, and plus 4 would be 180. And down here, we could call this negative 1, and this would be negative 2. So this is the standard deviation scale. So we could say that A is at plus 1 standard deviation, B is at plus 2, and C is at minus 1, and D is at plus 3. Okay, so we call that the z-scale. So we would say the z-scale or the z-score for A is plus 1. The z-scale or the z-score for B is plus 2. The z-scale or the z-score for D is plus 3. And for C, it's minus 1. Okay, so that's the z-score. Z-score. So how do we get the z-score? Well, we take, how do we know this is 3, 175? Well, we count. How many standard deviations is it above 160? So it's 1, 2, 3. But another way to say that is we take 175 minus the mean, 160. What's that? That's 15. So that's this distance from here to here is 15. And then we say how many standard deviations is that? That is, we divide that by 5 and we get 3. So that's why we get 3 here. So what about this one? then we would take B. We would take B would be 170 minus or minus 160. In other words, the distance between 170 and 160. And then how many standard deviations is that? Divide that by 5, and we would get 2. So that's why we get 2 here. Okay. And suppose then we had somebody that was here. Let's make that 167.5. So in other words, right in the middle between 165 and 170. So what would that be on the z-scale? Well, we have to go up 1 standard deviation, and then another standard deviation would bring me up to 170, but no, I don't go that far. I go a half. So it's what? So this score would be 1.5 standard deviations. So 167, how do we do that again? We say 167.5 minus 160. What is that? That's 7.5 over 5. 7.5 over 5 is 1.5. Okay, this 1.5. Okay? So what are we doing to calculate the z-score? What did we do? What if the standard deviation was not 5, but what if it was 10? So what if sigma was actually 10? Then what would 170 be? So it would be 160 to 170 would only be 1 standard deviation. So how are we figuring out the z-score? We're taking the actual value, which was 170. Let me just use it 170 in this case, but it's the actual value, which I actually want to denote by x sub I in general. But I'll just say 170 minus mu, minus the mean, divided by sigma. So that gives you the z-score. So if sigma is 5, then this is going to be 2. So we write that, generally we write it like this, x sub I minus mu over sigma. That gives you the z-score. Okay, so let's just review this once because the z-score is so important. So the z-score takes the actual score. In this case, the actual score was the actual height, and it transforms it. Right? So we start with, 175, and we transform that to 3. Or we start with 170, and we transform that to 2. Or we start with 165, and that was transformed to 1. Or we could start with 155, and that was transformed to -1. And we forgot to mention, but mu itself is transformed to 0, right? So anyway, it takes the actual height and it transforms it. It transforms it into a number, the number of standard deviations above or below the mean. So actually it's a measure of position. And the other measure of position that we've seen are percentiles. And it's very important. Okay, and this is the formula again, and we showed where this comes from. Sorry about that. Okay, so that is the z-score.